Okay, here's part 2. So let's go ahead and go to number 5. Example 5, that is. So we're still solving by grouping. So we're going to group the first two together. We're going to group the last two together. GCF of the first two is 3p. And after I factor out a 3p out of here, we're left with n. And then factor a 3p out of there, we're left with plus 5. Remember, you multiply back in, you should get exactly what you start with. 3p times n is 3np. Remember, alphabetical order of variables. 3p times 5 is 15p. So that worked great. Oh, we have two minus signs here, and both of these are positive. So if you see this, and remember, these are going to have to be the same. So here we could actually factor out a negative 4. And if we factor out a negative 4, that's going to make this a positive n, because negative 4 times n is negative 4n, and a positive 5, because negative 4 times positive 5 is negative 20. So this allowed it to work, plus it allowed us to have these two things together. So we're going to factor out the n plus 5, and we're left with 3p minus 4 when we factor out those. So what's left from the front after we factor out the n plus 5 is the p plus 3. What's left on the back side after we factor out the n plus 5 is the minus 4. Multiply back in, that's what you get. Remember, you should always, when you factor out, you should always be able to multiply back in to get the exact same thing that you just had. Okay, let's jump to the very last main idea, which is basically the idea of the additive inverse. And so basically with this is if you factor out a negative 1, you can change the signs. Whoops, not the signs, the signs. There we go, forgot my white out. Inside the polynomial. Oh, there we go. Sorry about that. Let me zoom out too. There we go. I had no idea you couldn't see that. So if you factor out a negative 1, you can change the signs inside the polynomial. Let's look at this example and let's see what that even means. So same thing. I'm going to group the first two, group the second two. GCF of the first two is going to be 2m. So that's going to be 2m. I'm going to end up with k minus 6. 2m times k, 2m k, all that works. Now I can factor a 7 out of this one. So I'm going to factor out a plus 7. And then here we are left with 6 minus k. We have a problem here. These are opposites. Positive k, negative 6, positive 6. So this negative 1 idea will help us actually flip these around and make sure that they're all the same. So in this case, if we factor a negative 1 out, it'll flip these signs. So when we do that, we get 2m times k minus 6. Negative 1 times 7 is negative 7. So I actually could have factored out a negative 7 to begin with and flipped everything. Then that will flip these around. It'll make the 6 negative and the k positive. So this is going to be times k minus 6. So let's look at this. Negative 7 times k is negative 7k. Negative 7 times negative 6 is positive 42. So by factoring out that negative, we were able to flip it around and make it work. Therefore, we end up with, again, my GCF now of this side versus that side at this level is going to be k minus 6. I factor out that k minus 6. What's left of the front part is 2m. What's left on the back part is your minus 7. And there you go. Okay. So let's go ahead and do one more example with these. With the factoring by grouping, there's going to be some manipulating that you're going to need to do in order to get them to work. Let's do one more example. This be example 7. This is also number 24 from tonight's homework. So for this one, we're going to do xy minus 2x minus 2 plus y. So let's do the same thing. So we're going to do the first two. We're going to do the next two. The GCF of the first two is just an x. And so we are left with y minus 2. Factor it, multiply it back in, you get the same thing. I don't see a GCF here. Also, everything seems to be kind of in a weird order. But, okay. So I have a y. The y is positive and the y is positive. The 2 is negative and the 2 is negative. So I'm just going to use the associative property, and I'm just going to go ahead and flip those around. Think of that as a negative 2. So this is actually going to be y minus 2 plus y minus 2. Okay, but now we have the exact same thing here. Okay, I just said a second ago that there wasn't a factor. What is a factor of a common factor of every number? Have you come up with it? 1. 1 is a factor of every number. So if they don't seem to have anything in common and you have to factor something out, you can always factor out a positive 1. So I'm going to factor out a positive 1 in this case because it was already the same, but I still need something here as a placeholder. And if you multiply something by 1, it doesn't change its value. So with this one, we're going to end up with y minus 2 once we factor that part out. And after I factor out the y minus 2, I am left with, in the front, I'm left with x. The second half, I'm left with plus 1. And there you are. Do not get stuck on any of the homework problems tonight. Don't let it give you a migraine or a headache. Just do the best you can, and then let's talk about these tomorrow. With these, it really just takes practice and getting used to manipulating things and putting them into forms that you can use and learning how to use them. So anyway, have a good evening, and I'll see you soon.